Good morning, students of Centurion University. I am Nimaya Chandra Giri from EC department, going to present lecturer on transistor, which is on the coming on subject of electronic device. These are the contents: objective, introduction, transistor structure, BJT transistor, transistor configuration, IV characteristics, operation mode of BJT, transistor act as amplifier, current, FET characteristics, MOSFET, and working principle of the MOSFET. So basically, coming under the transistor main chapter, under transistor it is divided into BJT and FET. BJT stands for bipolar junction transistor, FET stands for field effect transistor. Again FET is divided into JFET and MOSFET, junction field effect transistor, MOSFET for metal oxide field effect transistor. Okay. Another MOSFET is again divided into enhancement type and depletion type. Next, objective of transistor. If cells are the building blocks for human being life, similarly transistor are the building blocks for the digital revolution. In this modern digital world, everywhere transistor is used. So cell phone, computer, cars, in this way. Before transistor only vacuum tube and electromechanical switches are used in the circuit. But drawbacks is that in vacuum tube and electromechanical switch, those which are blocky in nature. Another thing is, for vacuum tube, heat is needed to emit the electrons. To avoid these things, we will use the transistor. Next, introduction to the transistor. Besides diodes, diode is a unipolar device. BJT is a bipolar device. Because of it depends upon the both positive and negative charge carrier, flow of the charge carrier. So transistor again divided into BJT and FET. Transistor is nothing but transfer plus ester. Transfer for ester means transferring the signal from lower level to higher level or higher level to lower level, means any levels to another level. But basically for transistor, it is transfer electrons are from lower level to higher level, because forward input side is forward bias, output side is reverse bias. So it fully depends upon the doping nature of the device. This is fast point contact transistor. In 1947. After that, in 1956, these 3 brilliant person got Nobel Prize for producing the transistor. In this point contact transistor, one spring is there, emitter is there, collector is there, base is there. Emitter, you know that emitter is used for emitting the electrons, base is there, which just act as a gate circuit, controlling circuit. Then again collector, which collect the, so its structure is very large. And nowadays it is reduced into those small type, small. So transistor is here. This is transistor BC547. So it has 3 legs: emitter, base, collector. Okay? You can also measure beta value by the help of transistor. You have to take mode on HFE, then you have to put transistor on multimeter. It gives some value, beta value, that is IC by IB, 300 something, 300. This is the beta value of transistor. So it can measure in this way by the help of multimeter. Right now, again. And next, this is the one example for transistor in daily life, your water tap. So basically bipolar junction depends on positive and negative charge carrier. It is mainly 2 types, NPN type and PNP type. For NPN, N has majority charge carriers electrons, P has majority charge carriers positive charge carriers. Again it is divided into NPN type and PNP type. So NPN series are BC547 next, and PNP series are BC557. One example of transistor. Now where water is coming, that is known as source. Where water is accumulated or controlled, that is known as base. Where water is hold down, collector. That much, how much you are controlled means that much will flow the water at the output side. This is an example. C for collector, E for emitter, B for base. So 3 terminals are there, emitter, base and collector. So emitter is a highly doped region, base is lightly doped, collector is moderately doped. So depends upon the doping, your transistor sizes are different. So basically in this way, this is the transistor size. This is the emitter, which region is more. This is the collector. Base, emitter, highly doped, lightly doped. So depending upon the doping nature of the transistor, current conduction also. Current conduction means fully depend upon the doping nature. Emitter is highly doped, means it emits more number of charge carriers. If it is N type, it emits electron. If it is P type, emit holes. And where base, a recombination process will occur. Means if electron is coming, so it recombine with the base. Let 100% electrons are emitted from the input side of the transistor, means emitter side, only 5% to 6% charge carrier are able to recombine. So after recombine, it gives current IB. Total number of electrons emitted 100%, it gives the current IE, and 95 electrons comes into the collector side. It contributes the current of IC. So IE is equal to, total current is equal to IE is equal to IE is equal to IB plus IC. It may be NPN, it may be PNP, but total current is equal to IB plus IC or IC plus IB. Next. Continue. This is the electron lightly doped collector, emitter is heavily doped, base is thin layer, and collector. Let 100% of electrons are emitted, maximum number of electrons are there. Here some positive charges are coming to recombine. After that only some percent of electrons are coming here to contribute the current IC. This is the transistor. And this is the symbols, current flow symbols. First one is PNP type, second one is, you know that IC unit is milliampere, IE unit is milliampere, IB is microampere. And NPN transistor or PNP transistor is nothing but it is the combination of two opposite type of PN junction diode. You can see there, one PN junction is there, another PN junction is there, combined to form NPN. Another PN junction is there, another NPN junction is there, combined to form PNP. In this way, a transistor is combined. Next. This is the bipolar junction transistor, how it is sandwiched. Let example of PNP type transistor. So N type semiconductor materials or layer sandwiched in between two opposite type of P type of materials to make into PNP. It is also similar for NPN. Next. This is the basic or current flow of the transistor. How current is flowing. Or this upper two diagram of the biasing of the transistor. Biasing is nothing but you have to give external DC supply towards the circuit. Then current flow is there. If you will apply KCL rule, it will give I is equal to IB plus IC. This equation. If you will apply the KVL rule, VEC is equal to VB plus VBC. From emitter base collector, this first one is PNP type transistor, second one is NPN type transistor. So current direction is there. For active region or conduction operation of the transistor, this input side is forward bias, output side is reverse bias. So input side forward bias means this is the NPN type transistor, N is your input. So N should be connected to the negative terminal, base should be connected to the positive terminal. For input characteristic only, for output opposite. This is reverse bias. So forward bias means its depletion layer thickness is very small. So maximum number of current can flow into the base. In the output side, depletion layer is more because reverse bias. So only 90% of electrons are able to conduct. The first emitter side, maximum number emitter side, maximum number of current are there. Only देखो 1 to 2 electrons are coming here to recombining. Here also recombining. Others are coming here. This is the emitter, this is the base, this is the collector, electron pole. Next, BJT is a current control device because of output current is directly proportional to the input current. But FET is your voltage control device. Voltage is given, output current is controlled. Next, transistor configuration. So transistor configuration mainly divided into these 3 types, but you have to require 4 terminals because for input side one E is there, another B is there. For output side one C is there, another B is there. So B is common for common base. So 2 terminal is common. That's why 3 type of configuration are coming. So if base is common, it means CB, common base configuration. So alpha is equal to IC by IE because B is common. For common emitter, E is common. So beta is equal to IC by IB. For common collector, gamma. These are the current amplification factors. And for common base, VB is the input, VCB is their output. Current is there, IE and IC. Next, common emitter. Emitter is common. If collector base, this is an emitter, so emitter is common. For last one, emitter, base, collector. So collector is common, so common collector. For first one, base is common to both sides. For second one, emitter is common to input and output side. For third one, it is common to both input and output side. So 3 types of configuration are there. If 3 types of configuration are there means it has also, each has input and output characteristics. Next, this is the input and output characteristics configuration of the transistor. Basically this is a common emitter type transistor. This is a common emitter. Another thing, from NPN and PNP type transistor, more popular is NPN type transistor. More popular is, and because of electron has more mobility as compared to holes. So N has majority charge करे electron, P has majority charge करे holes. So electron has more mobility, so it can easily move. So that's why NPN is more efficient and more reliable as compared to PNP type transistor. This is the input characteristic, this is the output characteristic. For input characteristics, you have to connect a ammeter at the IB region and voltmeter at the VB region. And fixed VCE. So if you will increase the VB value, supply value, by the help of your breadboard or anything here, if you increase the VB value or input supply value, source value, it will increases. Current will increases as per the increase of the voltage. If voltage is 0 means no current conduction will occur. So for output characteristics, similarly, you have to connect one voltmeter, one ammeter, and connect to another ammeter of the IB region. That range is 0 to 200 microampere, but I range is 0 to 200 milliampere. A voltage you can use 0 to 20 or 0 to 25 volt. So this is the output characteristics. In this output characteristic, you have to constant IB. You have to fix IB value. For input, you have to fix VC value. So in output characteristic, if you draw a load line, load line is nothing but it is the joining in between IC to VCE, IC to VCE, IC milliampere, VCE volt, 0. The load line. If you will join the load line, it will give a point on the load line. That point is known as Q point, question point or silent point. So one thing is that you have to maintain the question point or Q point at the middle position of the load line, because of it will give reliable output. Next, this is the load line where it is touched. This region is known as cutoff region. This is the saturation region. Upper part, straight part is known as active region. So basically your transistor has 3 regions of operation: active, saturation and cutoff. So for active region, input side should be forward bias, output side should be reverse bias. So for saturation region, both sides are forward bias. For cutoff region, both sides are reverse bias. So cutoff region, if both sides are reverse bias, it just act as a fully off mode of the operation. Saturation region has more number of current flow because of both sides are forward bias, so it has fully on. So fully off is there, fully on is there. So just transistor act as a switch. It is valid or not. If on is there, off is there, so transistor just act as a switch. Another application of transistor is transistor act as a amplifier. So therefore a transistor act as a switch because it may be operated in fully off and fully on. Fully off means cut off. Fully on means saturation, where maximum number of current are flowing. Next, transistor act as an amplifier. How transistor act as an amplifier? You can see internal structure, what is happened in internally. What is happening internally? First things. Three main things are there for amplifier purposes: Q point, varying beta value, and voltage gain. You have to maintain these three things. Then a proper amplification can be done through the transistor. First thing, Q point, how Q point is adjusted depends upon the RC value. You have to take RC value in this way. A Q point can be controlled, and your aim is to give Q point halfway along the transistor load line. Half, means middle position. This is the first motto. Second, varying beta value. If beta value is very, first I will measure by the help of multimeter beta value how much? 300. If it will after 1 minute or 2 minutes it changes into 250, result also changes. So you have to make beta value constant. So for beta value you have to use a voltage divider circuit. You have to use a voltage, because voltage divider circuit has more reliable output as compared to other type of fixed or cell biased or anything type of circuit. Next, voltage gain. Your another thing, one RE is there. RE, emitter resistance. If you will connect another capacitor across the RE, that capacitor is known as bypass capacitor. Bypass capacitor. That RE helps the voltage gain. You have to also make voltage gain should be proper manner, good manner, because voltage gain you have to require, because output voltage by input voltage is equal to voltage gain. Next, I will take one example. If input side supply voltage is 0.6 volt, you know that from 0.6 or 0.65 or 0.67 it will increase increasingly. So I will apply VB value 0.6 volt. You can see there, one mark it here. Input side, less number of current, less number of electrons are flowing. 1, 2, 3, 4, less number of electrons. In output side, you can see how much? If maximum number of electrons are flowing, means maximum current is there. So output side wave is obviously more as compared to input side. You know that input side resistance is very low, output side resistance is very high. I take one example. Let an example. VI, you know that 20 millivolt. RI is equal to 20 ohm. Means resistance very low, na? So 20 ohm. RO is equal to 10 kilo ohm. I will take 10 kilo ohm. Output side resistance maximum. Then RL, load resistance, is equal to 5 kilo ohm. Then I will apply. II is equal to VI by RI. VI how much? 20 millivolt. RI how much? 20 ohm. So is equal to 1 milliampere. So next, if I will take alpha is equal to 1, actually alpha value 0.999, which is approximately to 1. If alpha is equal to 1, then alpha formula is equal to IC by I. So IC obviously equal to I, approximately equal to. So that's why IL is equal to II. So IL how much now? 1 milliampere. Again, VL, load voltage. VL is equal to IL into RL. VL is given, RL is given. So VL is 1, IL is 1 milliampere and 5 is equal to 5 volt. Output side voltage is 5 volt, but input side voltage is only 20 millivolt. Output side is a volt range. So it is increases. So a V is equal to 5 volt by 20 millivolt is equal to 250, which is increase one. So output characteristic should be like this one. If input signal like this, obviously it is an amplifier circuit. It will give like means amplifier you have to use emitter circuit. Next, this is a current relationship. You know that I is equal to IB plus IC. You know that. So if I will divide IC, what will come? I by IC is equal to IB by IC plus 1. So IC by I is equal to alpha. So I by IC is equal to 1 by alpha. IB by IC is equal to 1 by beta. 1 by plus 1. So 1 plus beta by beta. So alpha is equal to beta by 1 plus. This is the relation in between alpha and beta. You can also find out the relation between alpha and gamma. You can also find out the relation between beta and gamma. This is the relation. Alpha and gamma relation is alpha is equal to 1 by 1 minus alpha. Gamma beta relation is gamma is equal to beta plus 1. Next, FET, field effect transistor. So in 1925 the fundamental principle of FET transistor was established by Field. Depends upon his name field, it gives the field effect transistor. So 1955 the first field effect transistor works. Actually FET has 4 terminals, BJT has 3 terminals. You can see. This is your JFET. Source, drain, gate. This one is substrate. But it has 3 legs. Emitter, base, collector. So JFET and BJT, it is also used as a switch, also used as a amplifier. BJT also used as a switch and amplifier. FET also used as a switch and amplifier. So again FET is divided into JFET and MOSFET. So JFET again divided into N channel JFET, P channel JFET. You know that N channel JFET is more preferable as compared to P because electron has more mobility. Next, MOSFET is again divided into enhancement type MOSFET, depletion type MOSFET. In enhancement and depletion type MOSFET, depletion has one channel, but enhancement has there is no channel. You have to create first channel, then you can transmit the charge carriers through the channel. But in depletion it is easy. Then again N enhancement type MOSFET divided into N enhancement type MOSFET, P. Then also depletion also N channel D MOSFET, P channel D MOSFET. Next, similar to BJT, 3 terminals control the output current. It is a voltage control device, but BJT is a control device. Next, similarity. Base, gate, collector, drain, emitter, source. Only substrate is other, or it is known as body part. So the more used one is the N channel enhancement mode MOSFET, also called NMOS. For P channel it is PMOS. So PMOS plus NMOS is equal to CMOS, complementary MOS. This is the FET architecture. This is the FET architecture. First one, JFET. देखो, red color is there lower side, from lower side. Red color is there. This is known as substrate. And upper this channel region is there where majority charge carrier passes. Then upper side, source terminal is there. Middle one is gate terminal. Another P-type gate is there. Then drain terminal. For MOSFET, in this way, only some different parts is there. One insulator material is there. That is known as silicon dioxide. And similar, all are similar to each other. It is the enhancement type, this is the depletion type. For depletion type, no conducting materials are there. Here is conducting region is there. Because of in enhancement there is no any channel. You have to create and conduct through the channel. These are the symbol. This is the JFET symbol. Inward means N type. Inward symbol means N type. It has inward means N type. And JFET biasing. You know that for biasing you have to connect external supply. So JFET is there, external supply is your outward power supply and inward power supply. You know that you have to make input side is forward bias. So that's why it is negative positive, it is reverse bias, positive negative. So it will also give input characteristic, also output characteristic. From output characteristic you will get FET just like as a switch. Huh? If you will give the as similar to BJT, if you will give some current resistance value, it will give at the output side more signal of the it is convert from weak signal to strong signal. That is amplification. Next, how FET works. In initial case means off case. Off case means there is no electrons are flowing through the circuit, means negative. You have to make, mind it, you have to make gate terminal to minimum voltage, 0 volt or positive voltage. If gate voltage is negative, no current conduction will occur. Only depletion layer will be increased. No current conduction will occur. In first case, you can see there depletion zone increases, but no current conduction will occur. If gate value is negative. Another case, if I will increase the gate value into 0 volt, electrons charge carriers are flowing. In opposite direction, current conduction will occur. So source, gate and drain. Next cases, 4 cases are there. If I will give VGS is equal to 0 and VDS is equal to 0, initial case, both are in 0 condition. What happen? Equal depletion region around PN junction. Source has some depletion region, drain side has some depletion region, so it should in equal manner. After second case, if VDS is negative and VGS is negative, means depletion increases but no current conduction occurs through the circuit. Third case, if VGS is negative, VDS is some positive value. VDS is some positive value, means it can 0 or more than 0, 1, 2, anything. 0.1, 0.2, 0.3, anything. It will give current slowly. If VDS is greater, means positive, or 0.1, 0.2, 0.3 or 1 volt, it will give more number of current or proper flowing of the current through the circuit. This figure. Understood? Next, JFET architecture. As similar to BJT architecture, JFET has output architecture. Active region, saturation region, pinch off or cut off region. Here there is no cut off, that is pinch off. If we will increase voltage more and more, after some times a depletion region comes like this manner. This is the JFET structure. If this is P is a N type at a base, then this is the depletion region. If you will increase more and more, this is the channel part. If you will increase VDS value more and more, it will increase in this way. One point will come, that point is known as pinch off, where no current conduction will occur or minimum, very minimum number of current are less amount of current flowing through the circuit. And ID is equal to IDS, 1 was VGS VTS, this is known as Shockley equation. And pinch off value I will written, the voltage at which the current flow between source and drain is blocked. Source to, current flowing from source to drain is blocked. Because the channel between these electrodes is completely depleted, is called pinch off voltage. Understood? Next one, MOSFET, metal oxide field effect transistor. So you know that 2 types, depletion mode, enhancement. Depletion mode has channel, but enhancement mode has initially there is no channel. You have to make it. You have to make it channel. How it will make? When there is no voltage on the gate, the device that does not conduct. More is voltage on the gate, the better device can conduct. Means you have to give more voltage at the gate region. So gate, that's why gate is known as a controlled area. Gate is known as controlled. So next, For N channel MOSFET, source and drain are N plus type and body or substrate is P type. For P channel it is opposite, means P plus and body is N region. This is the diagram for N channel depletion mode. This is the diagram for N channel enhancement mode. This is the symbol for depletion mode. This is the symbol for enhancement mode. One gap is there, means you have to enhance. So for N channel depletion mode, देखो, channel is there, but here there is no channel. For N plus means it emits large number of electrons. It emits large amount of electrons. Then electrons can come through this channel toward the D side. So for N channel MOSFET, so enhancement type, you have to increase. So gate region is there. This is the gate. This is drain. This is base. This is source. This is gate. This is drain. This is base. This is source. So enhancement, why it is known as enhancement? Because you have to enhance the mobility of charge carrier towards this. And gate is there. This is the control unit. You have to control. And another thing, main thing, your source terminal and drain terminal are heavily doped because source has to give electrons. Next, it is the working principle of MOSFET. You can see what are the structure, how MOSFET is structured. As similar to the JFET, it has also source terminal, gate terminal and drain terminal. Only one difference is that silicon dioxide is used, which is just act as a insulator. It create one region, red color. This is the depletion region, this red color. And for source, this is N plus. For drain, this is N plus and body is P type. For N channel type. For P channel type, it is N, it is P plus, it is P plus. And this is source, this is gate, this is drain. This is the simple structure of the MOSFET. And how it is worked. This is the depletion type. So first, it is fully based on modulation of charge concentration. Means MOSFET, it just act as a capacitor. Just act as a, that's why it is known as MOS capacitor. How it is just act as a capacitor? One thing, you have to make the capacitor, two electrodes are there, one dielectric material is there. Here also, body part is one electrode, just like one electrode, and source and drain type is another type of electrode. And middle part, gate part is known as dielectric layer. It is written based on MOS capacitor between the body and substrate and insulated from the other devices region. Gate is like as a dielectric layer, which is silicon dioxide. Next point, when we apply positive gate voltage, the holes present in the oxide layer experience repulsive force and the holes are pushed downward with the substrate. So this type of, I will take N type materials. So N is there, electrons are emitted. If I will increase voltage, this initially this type of present, initial case, N plus, this type, some gap is there. Here, some gap is there. For initial cases, source, gate. After increasing of voltage, it is just join. And your depletion region increases. This is the depletion region. Depletion region increases. So this is the working principle for NMOS type. So in below, VGS is 0 volt, current conduction occurs slowly, but when VDS is 0, means if you will increase VGS value more and more, depletion region only increases, no current conduction occurs. So you have to increase VDS value. VDS, source to drain value. After increase of source to drain value, a proper current flow occurs through the circuit. And length is channel, let it be, this is the length of channel L, this is the channel region, this is this region, this is the channel region. Channel, where charge carrier passes through the channels. And next, how MOSFET act as a capacitor. You can see P-type silicon is there at the body part. P-type is there. It just acts as one electrode. Upper part, conductive plate is there. So two electrodes are there or two plates are there. In middle section, insulator material is there. So it just acts as a capacitor. Next, if channel electron, how electrons are moving. And next is your how capacitor act as a MOSFET. You can read the depletion region is populated by the bound negative charges which are associated with the acceptor atoms. The positive voltage of gate, when you will apply some positive voltage at the gate, what happened? Attracts electrons from the N plus, which attracts electron from the N plus. N plus region is there in source, also in drain. Source and drain region into the channel, for example N MOSFET only. Then the electron, each channel is formed. Now if a voltage is applied between the source and drain, current flow freely between the source to drain. Then gate voltage controls the electron concentration in the channel. Instead of positive, if apply negative voltage, holes of channel will be formed beneath the oxide layer. So gate is just like as a here control. Another example I will show you. What is the application for the use of transistor? One example. This is a 12 volt DC supply. How it will 12 volt? Because you can find out. This is the bridge rectifier circuit. Because it has more reliable and more efficiency other two half wave rectifier and center rectifier. That's why I have connected a bridge rectifier. This is a small skill based project for our university. And resistor is there. This resistor is known as load resistors for filtering capacitor is, because output of the rectifier circuit is not a pure DC. To make a pure DC, you have to use a capacitor. After that, you have to make some voltage. You can also make 5 volt, you can also make 9 volt, you can also make 12 volt. This is a 12 volt. How? Because its name is 7812 CV. So it will give 12 volt. Also you can change. By the help of another series. I will see. This is, if you will connect this type, this is the 7-9 series. This is a 7-9 series. 7-9 series has more different. And this is the common point, this is the input point, this is the output point. Here connected. Here 5 is written. 5 means 5 volt. It is a 7-8 series. You can see 7-8 series. Likha hai. 780. So it has separate. Means it is a 5 volt voltage regulator circuit. And this is 7809. Means it is a 9 volt voltage regulator circuit. And this is the common point, this is the input point, this is the output point. Here connected. This section is connected to the transformer. And this section, this is the 12 volt output section. This is the 12 volt output section. So you can also change by the help of this voltage regulator IC or transistor. This is known as voltage regulator IC. This is only initiation of the skill based project. You can also made your mobile charger. Because mobile chargers require 5 volt, you have to use 7805. It will give 5 volt DC. Easily you can make the mobile charger in your home in less cost. And for this transistor, diode, one circle is there, that is known as negative part, and other part is positive part. Another is genodiode. Means beside transistor, diodes are there. This is the genodiode, very small part. One black round is there, that is known as negative. Other part is? It is fully of 6.2 volt. It is written, very small. It is written 6.2 volt. So genodiode, where it is applied, where it is used, voltage regulator circuit. You can use in your stabilizer for voltage regulation. It is also voltage regulator, 5 volt or 10 volt. So in this way, in everywhere, in your mobile, in your camera, in your projector, in everywhere, transistor is used. So this world is fully of transistor world. Without transistor, you cannot make digital revolution. You cannot make digital revolution. So transistor is more and more necessary. After transistor, IC are coming. In IC, so many number of transistors are connected internally. And next part. This is one example of the transistor used. Where transistor is used in modern railway system or in metro system. Transmit antenna is there is receive antenna. If any problem occurs in back-to-back bogie, it can transmit some signals toward the engine side. Where controller is there, it can control. Just like here is the emitter side, its source, it gives some signal. It is the control side, then it will give another output, emitter, base and collector. This is the one example of transistor. This is diode and one silver region is there. This is negative, this part is positive. It is only used for rectification purposes. And this is transistor. This is BJT transistor. This is BC547. BC547. This terminal is emitter, this is base, this is collector. 3 terminals. And this is JFET. 4 terminals. This one is substrate, this is source, this is drain, this is gate. This is the voltage range. W10, 10 voltage range. Written. This is the specification. And its specification is BC547. It is written. And this is the voltage regulator circuit. This is a voltage regulator circuit. Also written 7905. Means it is a 5 volt voltage regulator circuit. And this is 7809. Means it is a 9 volt voltage regulator circuit. And this is the common point, this is the input point, this is the output point. Here connected. And this is the 12 volt. So it is a bridge rectifier circuit and it gives only a pulsating DC value, and this is the load resistance RL which is connected here. RL, and if we want the pure DC value, to get the pure DC value we have to connect a capacitor value. It only used to get block the AC mixed component and give only DC, only pure DC. After that, if you will require only 12 volt, you have to use a 7812 IC value. It is written. It is a voltage regulator circuit. And this terminal, input, middle one is common and second terminal is output. It is connected here. From this side, the output is connected here. This is the output. And this is the input side of that rectifier where transformer is used, connected. This multimeter. For measurement of beta value of the transistor, you have to make into HFE range, and it is written as emitter base collector. This is the transistor, emitter base collector. So I have to connect emitter base and collector. When I have connected emitter and base collector in proper connection, it gives some beta value. This value is known as beta 306. If I will opposite it, it does not give value. Means small value, doesn't give value. So this is the way to connect. This is the emitter base collector. If I will connect here, it will not give some value. This is a misconnection. So you have to connect a proper connection of the transistor. It will give 308 or 309, some 300 something beta value. Our university is going to make skill-based university. So we have to use this type of component. Diode, transistor, ICs, voltage regulator devices, resistor, so many things. To make small project like this. This is a small project of 8 volt or 5 volt or 12 volt. You can make any type of things. So you can make all your adapter circuit or your mobile charger. It costs is 25 to 30. If any question, you can ask me about the transistor. This is the interaction section now. If any question, you can ask me. Otherwise, I will ask.
You were told that N-type and P-type, you are not told that means which type, if means I say, which means component, FET is mostly used or BJT?
Depends upon the cost. FET has more cost as compared to BJT. So in our daily life, we are using BJT, but FET is more efficient. And another drawback is that it has 4 terminals and it is more wide in nature. BJT is less wide in nature. And BJT also used as a switch or amplifier. FET also used as a switch and amplifier. Depends on the cost.
Sir, MOSFET is mostly or
MOSFET is better, but its cost is more. Series means BJT fast, resistor, diode, BJT, FET, MOSFET induces, this is a series.
In bottom region, there is no current or a little bit current?
Actually, in initial cases, only slow amount of current is flowing. That's why some graph, you can see the graph, left side. This graph, for this graph only little, small, very, very small. It is negligible, just like negligible. Sit down.
Sir, in FET, what is the function of substrate?
Substrate. Same in MOSFET, substrate has same. If you are not connecting any substrate value, no problem to the circuit because it requires some emit source terminal, gate terminal, and drain terminal. So substrate just like as a when we apply positive gate voltage, the holes present in the oxide layer experience repulsive force, and the holes are pushed downward with the substrate. Pushed downward. Those are not required. Which are pushed downward. This is the role of the substrate, nothing else. Thank you.